Hey guys, glad to have you back. We're going to be doing some more abstracts from NeurIPS 2022, medical set. These are three abstracts on medical datasets, medical related datasets. And we'll be doing this METS-CoV, DDXPlus, and FLamby. All right. So METS-CoV, a data set of medical entity and targeted sentiment on COVID-19 related tweets, is from Peilin, Zhou et al., coming from several universities, including Cambridge, Harvard, and this one's about named entity recognition, sentiment analysis, among other things. And the abstract reads, the COVID-19 pandemic continues to bring up various topics discussed or debated on social media. In order to explore the impact of pandemics on people's lives, it is crucial to understand the public's concerns and attitudes toward pandemic-related entities, for example, drugs, vaccines, on social media. However, models trained on existing named entity recognition (NER) or targeted sentiment analysis (TSA) datasets have limited ability to understand COVID-19 related social media texts because these datasets are not designed or annotated from a medical perspective. In this paper, we release METS-CoV, a dataset containing medical entities and targeted sentiments from COVID-19 related tweets. METS-CoV contains 10,000 tweets. It contains seven types of entities, including 4 medical entity types: disease, drug, symptom, and vaccine, and 3 general entity types: person, location, and organization. To further investigate tweet users' attitudes towards specific entities, 4 types of entities: person, organization, drug, and vaccine are selected and annotated with user sentiments, resulting in a targeted sentiment dataset with 9,101 entities in 5,278 tweets. To the best of our knowledge, METS-CoV is the first dataset to collect medical entities and corresponding sentiments of COVID-19 related tweets. We benchmark the performance of classical machine learning models and state-of-the-art deep learning models on NER and TSA tasks with extensive experiments. Results show that this dataset has vast room for improvement for both NER and TSA tasks. With rich annotations and comprehensive benchmark results, we believe METS-CoV is a fundamental resource for building better medical social media understanding tools and facilitating computational social science research, especially on epidemiological topics. Our data annotation guidelines, benchmark models, and source code are publicly available at a GitHub link that I'll put in the description below. And then it says to ensure reproducibility. So yeah, I'll have the links for the NeurIPS web page for this abstract where you can access the paper and this poster and some and other resources that they made available. All right, okay, on to the next one. This one is FLamby, Datasets and Benchmarks for Cross-Silo Federated Learning and Realistic Healthcare Settings, from Jean Ogier de Terrail et al., coming from several places in institutions in France, Paris in particular, also USC and UC Berkeley, and also looks like Germany and others. So several all over the world, it seems like. And this one is on healthcare federated learning. The abstract reads, Federated Learning FL is a novel approach enabling several clients holding sensitive data to collaboratively train machine learning models without centralizing data. The cross-silo FL setting corresponds to the case of few 2 to 50 reliable clients, each holding medium to large datasets, and is typically found in applications such as healthcare, finance, or industry. While previous works have proposed representative datasets for cross-device FL, few realistic healthcare cross-silo FL datasets exist, thereby slowing algorithmic research in this critical application. In this work, we propose a novel cross-silo dataset suite focused on healthcare, FLamby Federated Learning Ample Benchmark of Your Cross-Silo Strategies. That's the abbreviation, FLamby, to bridge the gap between theory and practice of cross-silo FL. FLamby encompasses 7 healthcare datasets with natural splits covering multiple tasks, modalities, and data volumes, each accompanied with baseline training code. As an illustration, we additionally benchmark standard FL algorithms on all datasets. And they also have a GitHub page that I'll have in the link below. And this one looks interesting. I'll have, like I said, more links so you can read more about this, their paper, and their slides as well. Okay, and the third I will share today is called DDXPlus, a new data set for automatic medical diagnosis, and comes from a group under Arsene, Tchango et al. And this one, again, is about automatic diagnosis, symptom detection, differential diagnosis, synthetic patients. Abstract reads, there has been a rapidly growing interest in automatic symptom detection ASD and automatic diagnosis AD systems in the machine learning research literature, aiming to assist doctors in telemedicine services. These systems are designed to interact with patients, collect evidence about their symptoms and relevant antecedents, and possibly make predictions about the underlying diseases. Doctors would review the interactions, including the evidence and the predictions, collect if necessary additional information from patients before deciding on next steps. Despite recent progress in this area, an important piece of doctors' interactions with patients is missing in the design of these systems, namely the differential diagnosis. Its absence is largely due to the lack of datasets that include such information for models to train on. In this work, we present a large-scale synthetic dataset of roughly 1.3 million patients that includes a differential diagnosis, along with the ground truth pathology, symptoms, and antecedents for each patient. Unlike existing datasets, which only contain binary symptoms and antecedents, this dataset also contains categorical and multi-choice symptoms and antecedents, useful for efficient data collection. Moreover, some symptoms are organized in a hierarchy, making it possible to design systems able to interact with patients in a logical way. As a proof of concept, we extend 2 existing AD and ASD symptoms to incorporate the differential diagnosis and provide empirical evidence that using differentials as training signals is essential for the efficiency of such systems, or for helping doctors better understand the reasoning of those systems. And since I have their paper pulled up, I will show you a little bit more. Let me zoom out a little bit in case you're interested. And there are other figures in here. All right, well, that is about it. And so that's 3 abstracts on these medical related data sets. I'll have another video coming out again soon on more of the medical related abstracts from NeurIPS 2022, as well as I have a few other playlists that you can listen to or watch and on NeurIPS and ICML 2023 medical related, and also other time series and others. All right, take care, guys. You have a good day. Bye bye.